So today what we're going to do is we're going to look at another way of displaying data. And the data we're going to look at is what's happening when you have two sets of two items to compare. Okay? And we're going to talk about that a little bit as we go. And they're called scatterplots. Now we're going to look at more types as well with different types of data. So far we've only measured data that had one attribute. For example, how many cats did you have, right? And it's just a number. Or what color is your hair? And it's just an answer. Yeah? But today what we're going to do is we're going to begin our look at what is called bivariate data. Now, do not be weirded out by that. I mean, you know these pieces. Anytime you see the word bi, that always indicates the number what? 2, like bicycle. And variate means a variable, which just means an unknown. So we have two variables that we're going to be looking at, right? So for example, we might be looking at age and height. Okay? And the reason, so we have two things there. First, we're going to ask how old you are. Second, we're going to ask how tall you are. So do you see that's two different unknowns or variables? And they're called variables because is everyone in here exactly the same age? Is everyone in here the same height?
Yes.
No. So they can be any value, right? And that's what a variable means. It can be any value. Its value can vary depending on who you're asking. So that's an example, a very classic example. Now, the point behind it, though, is that if I ask you your specific age and your specific height, that's two variables, but it's the same one person, right? That's your data. So each one of these is going to be 1 point on the graph. Okay? Because we want age and height at the same time. So each one of those corresponds to one person or one thing we ask. And we're going to look at several different examples. So you can see there are lots of them going on. And so we call these variables, again, because their value can vary. And we have what's called the independent variable.
And the dependent variable.
Yes, and the dependent variable. Excellent. Now with independent variable, that's the one that's never going to change. It's the one that everything is based on. Okay? So in this particular, and you can always tell which one's which by just putting it in a sentence. So let's just use age and height, for example. That's H-E-I-G-H-T, isn't it? Sorry. Anyway, now, listen to my sentence and tell me if it makes sense. Okay? Your height depends on your age. Or your age depends on your height. So how tall you are determines how old you are, or how old you are has something to do with how tall you are. What do you think? Yeah, so age, right? Because you tend to grow as you get older, right? To a certain point. So your age, in this case, is the independent variable. That's the one that everything's based on. And your height is the one that is changing based on your age. So if you make a sentence like that, or try two sentences like that, it's usually pretty easy to determine which one is your independent and which one's your dependent variable. Okay? Now, I'm not going to ask you a lot of questions about which one's which, but it is important as you move forward. And it's important to understand why things are where they are in the graph. Now let's talk about the graph itself. The graph itself is going to have two axes, in other words, two lines. And these behave like number lines. So number lines, the smallest number is to the left, then they get bigger as you go to the right. If it's up and down, the smallest number is at the bottom. They get bigger as you go up, right? So, and then you're going to have some scale. The scale does not have to be the same. So, for example, if we were going to do age and we were going to do height, okay, the independent variable always goes on the bottom, okay, and the dependent variable always goes up and down. Now, you're not going to have to draw these, but it's important that you understand. You're just going to have to analyze them or read them, but it's important to understand the basics behind it. So, okay, so what's the youngest age in here, you think?
Me.
What age?
12.
12? So say we have 12, 13, anybody 14? Probably not, right?
No, 13.
Everybody's 12?
Yeah.
Okay, well, all right. Let's just pretend we're doing more classes than this then. So notice our ages start at 12. There are some numbers between. So oftentimes you'll have this little zigzaggy thing there. That means you didn't do all the numbers. Now, if you start at 0, you don't have to put that. But if you start somewhere else, you might see that. Not always. Okay. Now, if you're doing heights, okay, then whatever height you are, okay, so who do you think is probably the shortest? Anybody want to volunteer to, okay? How tall are you?
I don't know, short.
In centimeters, you don't know how many? Who knows how tall they are in centimeters? Yeah.
158.
158?
167.
167? English student Annabella is probably going to.
162.
Okay, so you get some kind of range for there. So maybe this is 150, this is 160, this is 170, this is 180. Probably not going to have to go very much higher than that, no? Yeah? Maybe. But you see what, and again, because we left off some values, you usually get that little squiggle at the front. So I just want to show you what that little squiggle means. You'll see it sometimes. Now, not all graphs include that. Sometimes they don't bother. But what that means is we skip some numbers between getting where we started. Yeah? We didn't start at 0, in other words. Yeah? Okay. Now, so let's say you were 12 years old and you were 170. Was your height. So you would get a dot there. Now, that one dot represents both values. And it's just at the intersection of those values. So you go up from 12 to get to 170. So what if I had a 13-year-old who was 175? Go up from 13. 175 is halfway between 170 and 180. So I put a dot there. And each dot represents one person. Okay. What if I had another 13-year-old who was 160? 13, go up to 160 and get another dot. You can have more dots, right? Okay. So you see how it works? So we're going to look at a couple of these and just look at these. And I like Education Perfect for this because these are drawings and they've drawn it all out for you. And even some of them they've animated for you. Okay? So let's go there and look at some. So we're just going to look at this little exercise about reading them. And then we have to start talking about analyzing. Reading them is important. We need to understand how they read. So here we go. The scatterplot below shows the vertical leap of several ninjas along with the number of years they've been attending ninja college. Okay, so the years they attended is on one side, is at the bottom, and how high they can leap is on the side. And the reason they put the years attended at the bottom is because the longer you practice, the higher you should be able to leap, right? So the longer you're in school, the higher you should be able to leap. So let's just look at a few of these dots, and I want you to tell, and we're going to talk about what they mean. Okay, so we'll do this one together, and then I'm going to call on some of you. So here we go. This dot represents how many years attending the college? 2. And how high could that person leap?
250 millimeters.
Excellent. I can't tell you how proud I am that you put those units on there. Good. So 2 years, and they could leap 250 millimeters. You get it? Okay. So let me get some volunteers. And so that represents one person, yeah? So reading them is important, but the reading them is important so that you can then analyze them. So what we're going to do and what we're going to focus on is analyzing. Now, if you analyze something, that means you look at it and see if you can see some things about it, answer questions about it, right? So we're going to analyze these scatter plots. And so let's just go to the next section. So when you're analyzing scatter plots, what we're going to be looking at is a few different things of it. There are actually 4 things that you're going to be looking for. All right? So let's talk about just the 4 things that we're going to talk about. There we go. So analyzing the scatter plots, we're going to look at 4 elements. Now, You need to write these down, but then we're going to define each one as we go. So, the first thing, so analyzing scatterplots, you look for 4 elements. Okay? All right. The first one you're going to look at is called form. And when you're analyzing form, what we really mean is, does it look like a straight or curved line? So in other words, what kind of line could you draw that would represent the data? Does it look like they're all lined up in a straight line? Does it look like they're lined up in a curved line? We'll look at examples of all of these as we go too. Now, so that's the one we're going to look at first. Okay? Then, we're also going to talk in this section about direction. Okay? Does it look like that line is going up or is it going down? And we're going to talk about what that means and how to describe it. Okay? Now, okay. So those are the first ones we're going to look at. Strength means that you're going to look at how spread out they are. In other words, if they're really tight together, that means that means the strength is very strong. And if they're spread out, then the strength is weak or there's no relationship at all. And then finally, unusual features. We talked about this a little bit. These are the idea behind outliers, right? Things that don't fit with the rest of the data. And you're still going to be able to still see some of these there. And we're going to talk about how we talk about these things and what we should be looking for. Because there's a definite pattern for what we're going to be, how we're going to describe these. And that's what we're going to look at. And the first one we're going to look at is direction and the form of the relationship. So let's go there first. All right. So if you look at these 2 scatter plots, sample A and sample B, you can see an example of things that seem to line up in a straight line. Now these make a very straight line and they're very close together. Clearly, obviously a straight line. Do you see it? Now the sample B, they're a little more spread out, but we could still draw a line and they're pretty close to the line, aren't they? Right? They're not so spread out. They're not all over the graph. They still look like they make a collection that's going in a straight line down. Right? So this one, we would say that it's linear. Linear meaning line, right? And since that line is going up, that's why they put an arrow. You would normally never put an arrow, but you could if you wanted to. Since that line is going up, then we say that it is positive. So if I was going to describe this in a sentence, which is what you're going to have to do, I would say the data has a positive linear relationship. Again, why is it positive? Because it goes up. Remember, and this is a number line, so the smaller numbers are always on the left, and so you're going left to right when you're looking at this. Okay? Now, this one, anybody want to volunteer a sentence for this one then, based on what we just did? You answered a question. Go ahead, Amelia. There you go. Negative because the line is going what? Down, and linear because we can still draw a fairly straight line that will represent the data. Okay? Still kind of spread out, though, more than we'd like, but still linear. Okay? Good job. Okay. So think about that. You need to make sure you're answering in a complete sentence as you go. Now look at this information. If you look at this one is not a linear relationship. This one is a curve, right? And so not all relationships will make a straight line. This one is a curve, so don't worry about it. Can you tell me if it's positive or negative? Yeah, it's going down, so you could say that this one has a curve relationship, but we don't really, it's actually, this one is actually exponential, but who cares? You don't know that yet, and you don't worry about it. Well, we're going to focus on our linear ones, okay? That's our focus, but not everything is linear. Okay? And again, because it's going up or down, you get positive or negative. Make sense? Okay. Now, look at this one. Linear? Yeah, pretty much. Not too tightly close together, but yeah, we could draw a line there and represent that data. Positive or negative? So, this one has a positive linear relationship. Make sense? Okay. Let's look at the next one. Linear? Yeah, and you can tell because I can't draw a line that way or a line that way or this way or anywhere that really fits what's happening. So in this case, this is a non-linear relationship. Okay? And what we typically do is say there is no relationship. And if there is no relationship, then it can't be positive or negative. There's no relationship. Okay? So be aware that sometimes you get data that's just all spread out. Doesn't make any sense. Okay? Good. The other two that we're going to focus on is the strength of the relationship. First, how strong a relationship is. And there are 3 words for describing strength. So in describing strength of a relationship, you will describe it as strong, moderate, or weak. So those 3. You get no other choices, but you could use them together and say that it's moderately strong. Right? So you could, but you need to be able to justify it. Yeah? So we tend to try to stay with strong, moderate, or weak, but we could combine them if we're not quite sure. Just use them both. Yeah? And it's perfectly fine as long as it looks about right. Remember, in statistics, they're very seldom that you have a strong, definite answer. Okay? All right. So let's look at a couple of these so that we can see what those look like. Really simple. Here we go. Do these things look close together?
Yeah.
Then we would say that this has a strong linear relationship. Do you see that we could draw a line through it and all of the dots are pretty close to the line? Yeah? So this one is a strong,
Linear.
and what kind of linear? Positive linear relationship. Okay? Good job. So those are the descriptions you're going to use. So don't make it harder on yourself than it has to be. Okay? How about here? Linear?
No. Yes.
I'd say that's linear. Oops, sorry, my line's horrible, but there you go. It's linear. Strong? No, but pretty close to the line, so I would call this one moderate. Okay? Now, you could justify moderately weak, couldn't you? Because there are some points that are pretty far from the line, but I would say that's moderate. And it's what sign? Negative. Good. Thank you. Okay? Here we go. Could you draw a line?
No.
I would disagree. I could draw a line. They're just not that close to it, yeah? If you couldn't draw a line, they would be like this. Do you see the difference?
Yeah.
But we can really draw a line here. Okay? But we would describe this as what? Weak. Okay? Weak and what? Positive. So weak, positive, linear relationship. See the wording you need to use? Okay? We're not watching the quick video. But then you're going to analyze some on your own. Okay? Now, again, you can also have not weak, but no relationship. So be prepared. And the last thing we're going to talk about is some unusual points. This poor little bird. All right, some unusual points. And we talked about outliers before. They're just pieces of data that seem to lie outside the normal range. So, all right. So let's look at an example of this. So here we go. We have most of our data has a strong linear positive relationship. Do you agree?
Yeah.
But what's weird? That one outlier. Okay? So if you have something like that and you've checked your data, most of the time it's just a mistake. Okay? But if you checked your data and it's not a mistake, because this is saying that there's a 10-year-old guinea pig out there somewhere. Okay? Doesn't sound very practical, but it could happen, I guess. Anyway, so in this one, we could say that the data has a strong positive linear relationship with one outlier. But if you do say that, you've got to say where. The outlier is at 10 years and, what is that? About 800 grams, right? It's not exactly on 800. So if you do decide that something is an outlier, you need to identify it by its data, right? You must tell where that outlier is, okay? We can also talk a little bit about where this data is. So most of the data shows a positive linear relationship between 0 and what? 5 years? 0 and 5 years, okay? So we could also define that data. You could define a range for it. Remember, range just means how far they are apart, okay? All right. So if you do describe something as an unusual point, you need to talk about it. So here's what they've done. There it is. And they said this guinea pig is twice as old as all the others, because the oldest one in the group is 5, and that one's 10. Right? So it's twice as old as the oldest one in the rest of the group. Okay. All right. So what I'm going to do is I'm going to build you an assignment. We're going to start it now. These shouldn't take very long. You should have time to get most of them done, if not all of them. If not, then you will take it to do for homework. Okay? So we need to have these done before the next time we meet. Hold on just a moment. All right?